Hi, my name's Sam Bibow. I'm a doctoral researcher at the Experimental Music Technologies Lab at the University of Sussex, and today I'm going to be presenting Polaris, which is an audiovisual augmented reality experience built on mostly open source hardware and software. So, augmented reality has been typified in the last 20 years or so through numerous examples of experiences that layer information in front of participants' visual fields. And as we can see here, 96% of AR usability studies conducted between 2005 and 2014 augmented the visual sense. But of course, despite this paradigmatic form, there are cases where augmented reality applications and experiences fall outside the norm. If we're asking the question of how AR can facilitate the creation of new interfaces for musical expression, I'd argue that it's therefore key to take a broader and more holistic definition of AR. In my own practice, I work with the definition of real-time computationally mediated perception. The emphasis on mediation of perception here not only resaturates AR to include immersive experiences that provide more than just additive layering of virtual content, but it also empowers AR experiences that engage the non-visual senses due to the multisensory nature of human perception kind of being implied in the definition. So when setting out to create these AR experiences, it was important to me that I document my process, creating a sort of framework, if you will. It was doubly important that this framework facilitated the creation of gestural and expressive NIMEs that were reproducible, cost-effective, and privacy-respecting. And I believe that coming to AR experience design through this artistic and DIY approach liberates AR from consumer technologies, which are often prohibitively expensive, either require developers' licenses or agreement to privacy policies such as Microsoft's HoloLens 2 or Facebook's Quest 2. And the specific necessities of this framework included the 3D spatialization of real-time synthesis, as much open hardware and software as possible, and access to real-time or rapid prototype during use. So for audio, I chose to use bone conduction headphones as they allow simultaneous real-world and virtual world listening. And I opted for Leap Motion's Project Northstar AR headset as it's open source, 3D printable, and the sensors allow 6 degrees of freedom and fully articulated hand tracking, as well as 2K per eye resolution as well. It integrates with Unity, which I also decided to use, and although it's not open source, it's free and provides great learning materials. The audio is currently facilitated by libpd integration, a Unity package that allows full spatialization of pure data patches in the Unity scene with full send and receive object functionality too. So the Polaris experience itself is a room-scale audiovisual AR experience that allows users to interface with orbs, their hand movements subtly tweaking parameters that lead to both audio and visual feedback with them. And as well as this, their hands have the potential, if they click the button, to project particles that emit a constant noise, which is then filtered based on hand and finger pose. And there's a couple of videos of the studies that are shown here. And the videos that you can see are artificial layered composites of the Unity scene on top of video footage. The videos in the top right of the videos are also artificial first-person views, as I didn't want to affix a camera to the inside of the headset to capture the user experience. But the video on the previous slide shows what it's like to look through the lens. So I was interested in how users interacted with the experience and interviewed them during and after using a kind of broad interview technique, kind of positives and negatives. And the interview was kept broad because I used the grounded theory method to analyze them, aiming to extract relevant themes instead of coming to data with predetermined theories in mind. And so 7 hours of audiovisual feedback, the interviews and the experiences, were transcribed and coded, which led to 700 approximately individual codes that were then categorized into the following topics. So it wasn't only clear that the experience in question was able to elicit a wide variety of emotions, but to explain and make sense of them, the participants often made use of metaphors and past experiences. The participants identified it as a learning experience, with one pointing towards their unfamiliarity with the 3D headset technology, and others pointing towards the various interactive elements and the need to explore the scene that led to learning. For one participant, there was a connection between learning and immersion. And so within the context of musical interfaces, this could be taken to show that viewing the participant as a learner in these experiences during design could lead to a deeper level of engagement. And so unfortunately, the fact that the headset lacked a good fit for most participants was clearly what detracted from the experience the most. It led not only to a reduction in the experience immersion, but also to a lessening of comfort and a knock-on effect of muscle fatigue and inability to exercise full agency for some participants. Though it is worth mentioning that the issues with headset fit have since been addressed by redesigning the 3D printed headgear hardware. Apart from this, it was clear that the offer of a deeper interaction with subject matter increased the immersion of the experience, and the sense of this feeling or playing with virtual content led to participants envisaging AR's use in several artistic and musical contexts. And notable as well was the suggestion that these facets of experience, especially three-dimensional and context-specific sounds, could be employed to convey messages of socio-ethical importance as well as aesthetic experience. And it's also important to mention that some participants warned of negative side effects or the potential for negative experiences in AR, showing the importance of a safety-minded approach to designing such AR experiences. And so in terms of artistic expression and control, participants appreciated the ability to interact with their bare hands and felt that this was the main contributor to their expression in the scene. And this, for some, led to a feeling of power, and for some, a feeling of control over elements of the scene. And for others, the feeling of control wasn't entirely certain. And it was conclusive from the codes, from the grounded theory analysis, that some participants desired more control over the scene, although implementing this would have to be done thoughtfully without overloading the experience with content and parameters to change. Immersion tended to stem from the fact that the elements of the experience, sights, sounds, and actions were spatialized in 3 dimensions. Participants enjoyed and felt immersed by their movement, and also by the movement and color of visual elements, and were able to discern, as well as this, and localize the source of different sounds in the experience, several noting that this element for them was the most immersive factor for them. Others still preferred the visual elements, and some noted that their actions, the actions that they employed, the gestures and the movement of their body through the scene are what immersed them in the experience the most. So I'm currently exploring the system as a performance tool. I'm developing my performance practice with it and demonstrating its use at various events at Sussex. The next steps for me will be the exploration of 3 key topics that I see intersect with the system and AR as a whole: the way that our embodiment is extended through it, the way that hybrid space is constructed, and the way that materiality and tangibility is afforded in such systems. Thanks very much for listening, and I look forward to answering any questions that you may have.